What would the formula be to find the surface area or volume of the Earth? What about if we wanted to find out how much surface area was in a pyramid, or how much volume it contained? Hi, welcome to the lesson on surface area and volume of two-dimensional and three-dimensional objects. So when we're looking at the surface area of a three-dimensional object, this is the area around the entire outer surface. So if you're looking at a milk carton, that would be the four sides, the base, the pyramid at the top. And there are specific formulas that are used to find the area of different geometric solids like spheres or cones, or pyramids, or squares. Area is measured in square units, and surface area is also expressed in square units. So it'll be centimeters squared, inches squared, meters squared, and so on. We're first going to look here at a rectangular solid, and all of these formulas will be given to you in a formula sheet that you can use for any of the assignments that you are completing. So the surface area is calculated by finding the area of all three faces and multiplying them by 2 because there are 2 matching faces for all 3 different ones. So we have 2 times the length and the width for one of the faces, 2 times the length and the height, and 2 times the width and the height. So if this is the length and the width, so 15 by 6, so that would be, say, like the top and the bottom. And then we have 2 times the length and the height, so that would be the front and the back. And then we have 2 times the width and the height, and that would, say, be the left side and the right side. So when we're adding these all together, you can put them all into your calculator in one calculation, or you can calculate them separately. So always, just to be extra sure when you're calculating these, I'd put brackets around each section so that we know our calculator is doing the right order of operations. And if you do them separately, you can, but that just means you have one extra step to do because you'd have to put these 3 numbers in next. So the surface area of this entire rectangle, after we add all of the sides together, is going to be 684 meters squared. Okay, looking at a cube, this is a special rectangular solid because all 6 sides, 1, 2, 3, 4, the bottom, 5, and the back, 6, are the same. So you can take a cube and we'll go 6 multiplied by each side cubed. Or you can simply do the same as you would for a rectangular solid by going 2 times length times width, 2 times base times height, and 2 times base times length. Just, it's up to you. So in this case, all of our sides are 7 by 7. So we have 6 sides. Each of them are 7 centimeters by 7 centimeters for a total of 294 centimeters squared. Personally, I still treat cubes like I do rectangular solids, so that I'm only remembering one formula. Now the surface area of a cylinder is a 2-part formula. Now I'm just going to quickly draw one for you here. So we have a circle on the top and then a circle on the bottom. So when we make the net, which we'll see on a future slide of a cylinder, we have a circle followed by a rectangle followed by another circle. So we're going to go 2 times pi times the height of the side of the cylinder if it's a rectangle. Then we have to add the top and the bottoms of the circles. So the area of each of these is pi times the radius, or the radius squared. So and there are 2 circles, so we have to multiply this twice. So the surface area of a cylinder is 2 pi rh, and this is the side, or we could call it like the tube. And then 2 pi r squared. So this is 2 times the circle on the bottom and the circle on the top. So these are the circles on the top and bottom. And we multiply that twice because there is 2 of them. So here's our formula, and again, they'll all be on your formula sheet. So the surface area of a cylinder is 2 pi r, and our radius is 3 inches, times the h, height, 9 inches. So that's what we see here, 2 pi rh, plus 2, one for the top, one for the bottom, pi r squared. So you could go 2 times pi times 3, or 2 pi 3 squared in your calculator, whichever you prefer. So our total surface area of this cylinder is 226.2 inches squared. If we round, that would be 226 inches squared, to match our decimal places in our answer to our information in our question. Okay, now a cone. The surface area of a cone is, again, a two-part formula. We have the pi times the radius times the slant, which is going to give us the cone shape, plus pi times the radius, or pi r squared for the bottom. Now, our cone only has one circle, so we don't have to measure that, multiply that by its twice. So the surface area of a cone is pi r, and this S stands for the slant. If you were making a right angle triangle, this would be the hypotenuse. And pi r squared, which is one circle. So pi multiplied by 6, the radius, multiplied by 9 centimeters, the slant, plus pi 6 times 6, or pi 6 squared. And this gives us a total of 282.75 centimeters squared, or 283 centimeters squared. Okay, and one of our final shapes is the sphere. Now, the surface area of a sphere is found by multiplying 4 times pi times the radius, or r squared. So surface area is 4 pi r squared. When we put in the values that we have, we go 4 times pi times 5 times 5, or 4 pi 5 squared, and you can put that all in your calculator just like that, which gives us 314.16, or 314 meters squared. So again, all these formulas are given to you on your formula sheet. You can refer to it at any time that you need. So now a pyramid. Now when we look at this pyramid, it is 4 sides and 1 base, and that base is a square. But we can also have triangular pyramids that have 3 sides and 1 base that is also a triangle. So it really depends on what it looks like, and that's why there'll always be a drawing. So the surface area of a pyramid is found by multiplying 2 times the base edge of the pyramid times the slant height, and again, that's what S means, plus the base edge of the pyramid times the base edge of the pyramid. And this is going to give us the bottom. The base edge times the base edge. So sometimes it can match up. This one is 12 and 12. Other times it can be different. It just depends. Again, refer back to your drawing. So our surface area is 2 times the base times the slant. Okay. So in this case, our base is 12 and our slant is 9. So we're going to go 2 times 12 times 9 plus the base squared, because it's a square. So plus 12 squared. Also go 12 times 12. But again, that squared means the exact same thing. When we put that all into our calculator, we get 297 meters squared for the surface area of this pyramid. The volume of an object is the amount of space it occupies. We often measure volume to see how much we can put in to a container. So we'll have, like, our milk jugs will be 2 liters, or they might be 4 liters. We'll have pop cans that are 355 milliliters, and this is the volume that they hold. And that would be liquid volume, but we're talking about volume space. So it's the units of centimeters and milliliters can be interchanged when it comes to volume if you're measuring liquid. We're not getting into that in this course, but just to share with you. So volume is going to be expressed in cubic units, so centimeters cubed, inches cubed, meters cubed, etc. And the symbol for volume is going to be a capital V. And again, all these formulas are given to you on your formula sheet. So our volume is calculated by multiplying the length times the width times the height. In a rectangular or square pyramid, this is going to be the base, the depth, and the height. So you can put them in any order. 15 times 6 times 12 gives us 180 meters cubed. Again, put that right into your calculator. Now we're going to look at some examples where we're looking at calculating the volume of these different prisms. We're also going to be drawing the nets to make sure that we are getting all the sides when we're calculating our surface area. So this is a rectangular prism, and we're going to have the general formula of volume and how it relates to the height of our object. So our area of the base, how much linear space that takes up, and then we're going to multiply that by height to get our volume. So the volume of this rectangular prism is equal to length times width times height, 5 centimeters times 3 centimeters, and it does not matter what you associate the 5 and the 3 with. You could have them switched if you'd like, multiplied by 2 centimeters. And this gives us a total volume of 30 centimeters cubed. Now note, from surface area, we're changing that to a 3 up there instead of a 2 for cubed volume. Now we're going to look at the net of that three-dimensional shape. So you can label these. We might say this was going to be the top, the bottom, the left side, the right side, and then like the front and the back. It just depends on how you're looking at it. But just to give you an idea of, these are the shapes that we have on our cube. So our long edges here are 5 centimeters. Okay. Our little short ones there are 2 centimeters. Our medium length ones here are 3. And those are the different shapes that we have. So if we look at our bottom and our top, they are the same size. They both are 5 by 3. So our area is going to be equal to 2, the top and the bottom, multiplied by 5 times 3, and this gives us 30. We also have the area of the front and the back, and this is going to be 2 multiplied by 3 multiplied by 5, multiplied by 2. They're quite small. And so that would be 12. And then we have our area of, say, our left side and our right side. And it's 2 is equal to 5 times 2, or 20. Then adding all these up together gives us a total of 62 centimeters squared. Now, it doesn't matter if you had the front being 5 times 2 and the left and right side being 3 times 2. We just want to know that you know that there's 2 of each matching side. Okay, now we're going to determine the volume of this shape here. And it says the number of cubes. And that's just reminding you that that is the volume, the space that that entire shape takes up. We're not going to get you to count cubes. So the volume of a rectangular pyramid is equal to the length times the width times the height. So 10 times 6 times 4. And these are all in meters, so we don't have to convert anything. And this gives us a total of 240 meters cubed. Now we're going to look at the surface area. So if I draw this out as a net, and forgive me because my drawing is not great. So we're going to have 4 of the longer ones. And then we have our front and our back, which are a little bit smaller. Mine is definitely not perfect. So this is going to be 6 and 6 in those. 6 and 6 here. We have 4, 4, 4, 4. And these ones here are also 4. Okay. And then across the middle, we have 10s for everything. So a net is if we took that 3D shape, cut all its sides, and then unfolded it. So now looking at our surface area, we have 2 multiplied by length and width plus 2 multiplied by length and height plus 2 multiplied width by height. So 2, 10 times 6 plus 2, 10 times 4 plus 2, 6 times 4. And you could break this all down. We would get 120 plus 80 plus 48 gives us a total of 248 meters squared. You could also just put this all into your calculator, 2, 10 times 6 in brackets, plus 2, 10 times 4 in brackets, plus 2, 6 times 4 in brackets, and it will give you that answer without having to do that middle step. Okay, we're now going to look at a triangular prism. Now, the nets of these look a little funny when we get to that one. So we need to imagine that it is standing on its end. So that we can do the area of the base, which is going to be a triangle, multiplied by the height. So the area of a triangle is equal to base times height divided by 2. And in this triangle, ignore that 6, it's a typo. It should be 3.0 multiplied by 2. And that's going to be the height of our base and height of our triangle. So this is equal to 3 times 2 divided by 2, which is going to equal 3. Now we're going to take that, our area is 3, we're going to multiply it by the height, which is 5 centimeters. So our volume is equal to the area of the base multiplied by the total height. So we're going to take our 3 centimeters squared multiplied by 5 centimeters, and we get a total of 15 centimeters cubed. So you don't have a specific formula for these triangular prisms, except for the area of the base times the height. So they need to be standing vertically for that math to work. So now we're going to determine the surface area of this shape, and here is the net drawn out for us. So if you refer back to the numbers in the previous slide, our heights, our long sections are all 5. Then we had 3 centimeters. Two, 2, 2. 3, 5. Okay, so we're going to do this math together. So we have this section, we're going to calculate the area of sections 1, 2, 3, and then here we have matching ones at 4. So the area of our first section is going to be the length times the width. So this is equal to 5 multiplied by 2, or 10 centimeters squared. The area of our second section is equal to length times width, or 5 times 3, 15 centimeters squared. Okay, section 3 is also length times width, which is equal to 5 times 3, or 15 centimeters squared. Now we have section 4, which is going to be length, or base times height, divided by 2. And we have 2 of these sections. We have top and bottom. So we're going to multiply that by 2. So 2 times 3 divided by 2 multiplied by 2 is equal to 6. So then we add these all up together. We have 10 plus 15 plus 15 is 40 plus 6. So we have 46 centimeters squared for our surface area. Okay, we have one more here that we're going to be determining the volume. So again, we're going to look at the area of the base multiplied by the height. So we're going to stand it on its end. Okay. And we're going to have 4 multiplied by 6 divided by 2, because it's a triangle. So area is equal to 4 multiplied by 6 divided by 2 gives a total of 12 meters squared. Now we have to take the area of the base multiplied by the height of that whole shape, which is going to be 10 meters. So 12 meters squared times 10 meters is equal to 120 meters cubed. Okay, moving on to let's go through, and we're going to now redo that one with finding the surface area. I didn't give myself another slide. So again, referring to the numbers on the bottom here, we have 3 sides to our triangular prism and a triangle base. Oops, and a triangle top. So again, forgive my poor drawing. Nobody's getting marked on how well they can draw geometric shapes. So these are both 4. We have a 10 here. All the middle ones are 10. Okay, our slant here is 7.2. That's not the height, that's the slant. Again, here we'll have 7.2 and 4, so those top and bottom match. We have 6 in the middle, 7.2 here as well. So here's all our sides. So none of them match except for the top and the bottom. So again, we're going to go 1, 2, 3, and then 4 for the top and the bottom, and we have 2 of them. So area of side 1 is equal to length times width, which is equal to 10 times 4, or 40 meters squared. Area of section 2 is equal to length times width, 6 times 10, so 60 meters squared. Oops. Area of section 3 is equal to length times width, which is equal to 10 multiplied by 7.2, which is equal to 72 meters squared. And area of section 4 is equal to 2, because there's 2 of them, multiplied by base times height divided by 2, which is equal to 2, 4 times 6 divided by 2, to be 24 meters squared, all giving us a total of 196 meters squared. So there are a lot of steps to figuring out these triangular 3-dimensional shapes, but drawing the net will really help you make sure that you get every side calculated. So now we're going to move on to cylinders, cones, pyramids, and spheres. So for cylinders, what shape is the base? The shape of a base in a cylinder is a circle. Okay. So what is the area of the base? The area of the base is going to be pi r squared. So that's what we're going to calculate first. So for A, we're going to go the area of the base, or this, is equal to pi r squared, which, and they gave us pi, or they gave us r, pi times 3.4, and remember to use the pi symbol, squared, which is equal to 36.3 centimeters squared. Now we're going to calculate the volume. So volume is equal to pi r squared multiplied by the height. So we've already calculated that, but we can put our numbers in again. Pi 3.4 squared, put this all into your calculator, multiplied by 10.0, and we get a total volume of 363 centimeters cubed for our volume. Okay, now we're going to take a look at surface area, and we have two circles that are identical, and then we have this rectangle in the middle. So for our surface area, we're going to go 2 pi r squared plus length times width of that rectangle. So 2 pi 3.4 plus 10 times 21.4. Sorry, I missed a step here where I have to calculate the circumference of that circle, which is going to give us the length here. So just moving down here so I have a little bit more space. The length of this, like I said, rectangle is going to be the circumference because it goes all the way around. Oops. And circumference is equal to 2 pi r. So 2 times pi times 3.4. And if you put that into your calculator, it's 21.4. So then we move that number up into our other equation. So now to put all our surface area in together, 2 times pi times the radius for the top and the bottom, multiplied by 10, which is the height, and 21.4, which is the length of our rectangle, which was the circumference of the circle. And our total volume is equal to, or our total surface area is equal to 286.6 centimeters squared because it's surface area. Okay, we have a couple more diagrams here where we're going to find surface area of a cone as well as of a pyramid. So for the surface area, this is equal to pi r squared plus pi rs. And again, that s is the slant height of 20.1 meters. So pi multiplied by, we have to find r. So our diameter is equal to 18 meters. Divide that by 2. We get 9 meters as equal to our radius. 9 squared plus pi 9 times 20.1. You can put this all into your calculator just like that, or you can do two separate steps. If you do two separate steps, this should be 254.5 plus 568.3, giving you 822.8 meters squared. So this is a really nice one, our only two steps, where we have to calculate the radius from a given diameter. So looking at our square pyramid here, we end up with 4 symmetrical or identical, triangular sides and then 1 square in the middle. So our formula for the triangles is base times height divided by 2, and the square is length times width. So our area is equal to length times width, that's going to be the base, plus base times height divided by 2, multiplied by 4 because there's 4 sides. That's our number of sides. So this is equal to 11 times 11 plus 4 multiplied by 11 times 10.5 divided by 2. And you can put this all entirely into your calculator. If you do it in 2 steps, you have 121 plus 231, giving you a total of 352 yards squared. Okay, and our last 2 questions here are going to be finding the volume of a sphere and our triangular pyramid. So looking at our sphere, our formula is equal to volume is equal to 4 divided by 3 pi r cubed. And we're given the diameter. So to find the radius is equal to the diameter divided by 2. 16 divided by 2 is equal to 8 centimeters. Moving that into our formula, 4 divided by 3 pi 8 cubed gives us 2,144.7 or 2,145 centimeters cubed. Now the volume of a square pyramid is equal to the area or base length times width, so the area of the base times the height, divided by 3. So this is going to be 8 times 9 divided by 3. We can just put this all straight into our calculator, and I'll get a volume of 192 kilometers cubed. So this would be a gigantic pyramid that is 8 kilometers square and 9 kilometers high. Absolutely massive. So again, you have a formula sheet providing the formula for these different shapes available on Canvas. Refer back to the video at any time, and have a good luck completing your own assignment.
If you enjoyed this video, check out our website, online.plrd.ab.ca, and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.